Hello guys, welcome to the lecture 3 of machine learning series. In this video, we'll be discussing another important and interesting topic, that is different types of machine learning. Okay, based on the amount of supervision given to a machine learning model, we classify machine learning into four different types. Okay, among them, first is supervised learning, second is unsupervised learning, third is semi-supervised learning, and fourth is reinforcement learning. Okay, now based on the input data, okay, based on the type of input data we give to a machine learning model, we classify supervised learning into two different types. Okay, first is regression and second is classification. Okay, similarly we classify unsupervised learning into clustering, dimensionality reduction technique, third is anomaly detection, fourth is association rule based learning. Okay, followed by semi supervised learning and reinforcement learning. Okay, in this video our aim is to discuss each of these types in detail and also discuss in detail about the sub classifications. Okay, among different types of machine learning, let's understand our first type of machine learning, that is supervised learning. Okay, now what we actually do in supervised learning is, first we take a machine learning algorithm. Okay, we take a machine learning algorithm and we train. Okay, we train this machine learning algorithm on an data. Okay, on an data. Okay, now how this data looks like is, it has input as well as output. Okay, now we train this machine learning algorithm on this data which contains input and output. Okay, now what this machine learning algorithm does is, it finds a mathematical relationship. Okay, mathematical relationship between this input and output. Okay, it finds a mathematical relationship between this input and output. After finding out the exact mathematical relationship, when a new data sample comes, okay, at the time of prediction, when a new data sample comes, through this mathematical relationship it finds out the output. Okay, through this mathematical relationship it finds out the output. Okay, this is called supervised learning. Okay, in supervised learning we train and machine learning algorithm on a labeled data. Okay, in short, how and supervised learning can be defined is, supervised learning is a type of machine learning where it train and machine learning algorithm on an labeled data. Okay, on a labeled data. Okay, now let's see with an example. Let's say we have input as well as output. Okay, where we have input as an image. Okay, as an image of a dog, cat, dog. Okay, let's say we have three samples where our first image is dog, second image is cat, and third image is dog. Okay, now in output, okay, in output we give the label. Okay, we give the image label. Okay, at the output we give the image label. At the input we just give an image. At the output we give the image label. Okay, this is dog, this is cat, and this is dog. Okay, now when you train a machine learning model, okay, machine learning algorithm on this data, okay, when you train a machine learning algorithm on this data, what your machine learning algorithm does is, it finds out the mathematical relationship between this input and this output. Okay, it finds a mathematical relationship between this input and this output, and in future when a new image comes at the time of prediction, through this mathematical relationship it finds out the output label. Okay, through this mathematical relationship it finds out the output label. Okay, this is basically entire supervised learning. Okay, now this supervised learning is classified into two different types. First is regression and second is classification. Okay, now before understanding what actually this regression and classification are, we need to understand another topic, that is different types of data. Okay, we need to understand what are the different types of data. Okay, now first we have numerical data. Okay, data is classified into numerical data and categorical data. Okay, numerical data can be said as, where in a data set, okay, where in a data set in the output column, okay, only at the output column if we have numerical values. Okay, at the output column if we have numerical values, then we say it as numerical data. Okay, if at the output column, okay, in the same data set, sorry, at the output if we have categories. Okay, if we have categories that are classes, then we say the data as categorical data. Okay, now for the example, we can take as age, mm, house price prediction. And when it comes to categorical data, we can take as gender, dog versus cat classification. Okay, now when we train and machine learning algorithm on the numerical data, then we call it as regression. Okay, when we train and machine learning algorithm on a numerical data, then we call this as regression. Okay, if else we train the machine learning algorithm on the categorical data, then we call it as classification. Okay, now let's see an example. Let's say we have an input data set where we have mm, rooms, floors. Okay, let's say floors and price of the house. Okay, this is our data. Okay, where rooms and floors are inputs and price is the output. Okay, where room and floors are the inputs and price is the output. Now price is generally a numerical value. Okay, the price is always a numerical value. Okay, now we train our machine learning algorithm on this data. Okay, what our machine learning algorithm does is it finds the relationship between the input and output. Okay, it finds a mathematical relationship between the input and output. After finding the mathematical relationship, what it does is at the time of prediction, when a new data sample comes, it tries to predict the price of the house. Okay, it tries to predict the price of the house, which is a numerical value. Okay, which is a numerical value. So we say this entire problem as regression. Okay, we say this entire problem as regression. Okay, now for example of classification, we can take this as an example. Okay, this entire example is classification. Okay, this is basically entire supervised learning and its sub classifications, that is regression and classification. In the next section of the video, we'll be seeing about unsupervised learning. Now let us discuss our second type of machine learning, that is unsupervised machine learning. Okay, now let us see how actually this unsupervised machine learning works. Okay, first we'll take an machine learning algorithm. Okay, first we'll be taking a machine learning algorithm. Then to train this machine learning algorithm, we need data. Okay, let's say this is our data. Okay, now the basic difference between supervised machine learning and unsupervised machine learning is, in supervised machine learning, in data we have input followed by output. Okay, we'll be having input and output. But in unsupervised learning, in our data we'll be only having input. Okay, there will be no output in our data. Okay, there will be no output in our data. Okay, there will be no output in our data. Okay, this input means input features. Okay, we'll be only having input features in our data, means our machine learning algorithm will be trained only on the input features. So our machine learning algorithm will be finding the common features. Okay, the important features among the input features. Okay, we'll be finding more similarities between the input features. Okay, this is how unsupervised machine learning works. Okay, so finally we can define unsupervised machine learning as, the unsupervised machine learning is a type of machine learning where we train an machine learning algorithm on an unlabeled data. Okay, unlabeled data is nothing but the data with no output. Okay, no specific output, will be only having input. Okay, now in this unsupervised machine learning we'll be having four techniques. First is clustering. Second is dimensionality reduction, dimensionality reduction. Third is anomaly detection. Okay, anomaly detection. And fourth is association, rule based learning. Association, rule based learning. Okay, now among these four, first we'll be discussing clustering. Okay, clustering is a very important technique. Okay, clustering is a very important technique which we'll be discussing in detail in our further videos. Okay, now let's see a basic overview of this clustering. Let's say we have a data set where we have two features and output. Okay, now in this data set I'll be having first record, second record, the third record, fourth record, fifth record, and sixth record. Let's say I have 6 rows of data. Now initially what you actually do is you plot this entire data. Okay, initially you plot this entire data. Okay, after plotting the entire data you will be fixing two data points. Okay, you will be fixing two data points, that is these two data points are called centroids. Okay, I'll be explaining this clustering and what is meant by centroids in my further videos, but just have an idea. Okay, just have an idea about how clustering works. Okay, now let's say these are my fixed data points. Okay, let's say these are my fixed data points. Okay, initially I'm considering two, but you may take three or four. Okay, according to the data you may take three or four. Okay, but I am fixing two as my clusters. Okay, sorry, I'm fixing two as my centroids. Okay, now what you actually do in clustering is first you select this data point. Okay, you select this data point. Now you calculate the similarity between this data point and this fixed data point. Okay, and this data point to this fixed data point. Okay, now if this data point is more similar to this fixed data point, you consider these both as a cluster. Okay, you consider these both as a cluster, right? Now you take this data point, right? Now you compare, again you compare the similarity scores between this data point to this fixed data point and this data point to this fixed data point. Now let's say it is more similar to this fixed data point, so you consider this data point into this cluster. Okay, now again you take this data point. Okay, now you compare the similarity scores between this data point to this data point and this data point to this data point. Let's say it is more similar to this data point, you'll be consider this has a cluster. Okay, now again you do the same thing with this and this forms a cluster. Okay, so overall when you keenly observe, there are two clusters being formed and the data points in each cluster are more similar. Okay, each data point in the cluster is similar to each other. Okay, is much similar to each other. So this data set sorry, this plot specifies more information about how many labels. Okay, how many labels we have in our data. Okay, we have in our data, and this clustering also helps in labeling our, okay, labeling our data points. Okay, now let's say this is our dog cat classification data set and you have two clusters over here. Okay, now among these two clusters, according to your data, you can name each cluster as a label. Okay, you can leave, sorry, you can give each cluster as your own label. Okay, as your own label. Okay, this is clustering. Now you may have a doubt that I have two features over here, so it's an 2D plot and I am able to visualize the clustering. Okay, now let's say if I have in dimensional data, is clustering done? Yes, the clustering is done even when the data set has n-dimensional data. Okay, the clustering is done even the data set has n-dimensional data. Okay, so this is all about clustering. Okay, now our second technique is dimensionality reduction. Okay, dimensionality reduction. Okay, now let's first basically understand what actually are these dimensions. Okay, what actually are these dimensions? Okay, I have said that this is my data set. Now in this data set, if you keenly observe, these both are my input features. Okay, these both are my input features, so I got an two-dimensional plot. Okay, I have two features, so I got an two-dimensional plot. Means the number of features are equal to okay, number of features are equal to number of dimensions. Okay, number of features are equal to number of dimensions. Means these dimensions are nothing but number of features. Means these dimensions are nothing but number of features. Okay, now what is the actual requirement of reducing this number of dimensions. Okay, now the actual requirement of reducing this dimensions is, let's say we have, let's say with an example. Okay, now let's say we have data where we have uh, m1, m2, m3, m4, AC, like we have n number of features. Okay, let's say this is a college placement data, and these are the grade points in each subject. Okay, these are the grade points in each subject from the very first semester. Okay, these are the grade points in each subject from the very first semester to the very last semester. Okay, so in this case I'll be having n number of subjects. So for this n number of subjects I'll be having n number of grade points. Okay, I'll be having n number of grade points. Okay, now when you train on an machine learning algorithm on this data to detect whether a student will be placed or not. So it, what actually the machine learning algorithm does is, it tries to overfit. Okay, it tries to overfit means about each student it learns in detail. Okay, it learns in detail. Okay, overfitting is nothing but about each row it is learning in detail, means about each student it is learning in detail, and it is trying to concentrate on each and every student. Okay, it is not trying to generalize, but it is trying to concentrate on each and every student. So in this case we'll be facing the problem of overfitting. Okay, now you may think, what is the problem with this overfitting? Okay, this overfitting will cause lack of generalization. Lack of generalization means you're just mugging up the concepts. Okay, you're just mugging up the concepts of an subject, but not generalizing. Okay, but not generalizing the topics. Okay, this is the overfitting. And there is another downside of this having n number of dimensions, that is training time. Okay, the training time also increases when we have more number of dimensions. Okay, these are the disadvantages of having more dimensions in our data. So we need to reduce the number of dimensions in our data for faster training, and also to reduce the problem of overfitting. Okay, for this dimensional reduction we'll be having many techniques like PCA and LDA. So okay, we'll we'll be discussing about those techniques, and also in detail about this dimensional reduction in our further videos. Okay, now third type of technique in unsupervised learning is anomaly detection. Okay, now let's understand anomaly detection with an example. Okay, now let's say we have machine learning algorithm. Now I'm training this machine learning algorithm on an data. Okay, now in this data, let's say I have only not spam mails. Okay, I'm making an email spam classifier. Now in this data set I have only not spam mails. Okay, entire data set has an not spam mails. Okay, now when I train this data with when I train this algorithm with this data, now my algorithm will try to learn how to detect and not spam mail. Okay, it only concentrates how to detect and not spam mail, but not as spam mail. Okay, our entire machine learning algorithm will only concentrate. Okay, will only concentrate to detect and not spam mail. Okay, it will only concentrate to detect and not spam mail, but it won't try to detect how spam mail looks like. Okay, it won't try to predict how whether an email is spam or not. Okay, now in future, okay, in future if I have an spam mail, okay, for example, if I have a spam mail for prediction, now this machine learning algorithm will treat this spam mail as an anomaly. Okay, will treat this spam mail as an anomaly. But when I test with an not spam mail, it will try to predict the class as not spam. Okay, it will try to predict this class as not spam, but it will not try to able to predict this spam mail because it has not seen any spam mail at the time of training. So it will treat this as an anomaly. Okay, it will treat this prediction as anomaly. Okay, now this anomaly detection can be exclusively used for outliers. Okay, outliers. This anomaly detection can be exclusively used for outliers. Okay, outliers are nothing but the unsimilar data points. Okay, now let's say all these points are not spam mails. Now in future when I have spam mail, it will be over here. Means it is entirely different from these data points. Okay, it is entirely different from these data point. So this becomes an outlier. Okay, so anomaly detection is nothing but it helps in detecting the outliers. Okay, now my fourth technique is association rule based learning. Now let's understand this association rule based learning with a small example. Okay, now let's say we are trying to establish a supermarket. Okay, now in that supermarket I'll be having thousands of products. Okay, now to place this thousands of products in the stacks, I need a technique. Okay, to place this thousands of products in the stacks, I need a technique. Okay, why do I actually need a technique is when a customer buys a milk, he will also try to purchase a bread or jam. So if I place this milk and bread or jam beside stacks, I'll be having better sales. Okay, I'll be having better profits for my business. Okay, else if I place this bread and milk randomly, first my customer buys milk and then he searches for bread. Okay, so in searching, he's wasting his time. So he'll think, why do I actually need to waste the time? So what you need to do is you need to collect the bills of supermarkets. Okay, you need to generally collect the bills of supermarkets, and you need to train a machine learning algorithm on this bills. Okay, now when you train a machine learning algorithm on this bills, it the machine learning algorithm will tell us that which products to be placed in the beside stacks. Okay, which products to be placed in the nearby stacks. So due to this, the sales of the company can be increased. Okay, the sales of the company can be increased. Okay, this is the basic working of association rule based learning. Now let us discuss our last two, but let's frequently use type of machine learnings, that is semi-supervised machine learning and reinforcement learning. Okay, now when it comes to semi-supervised machine learning, it is partially supervised and partially unsupervised. Okay, and partially unsupervised. Okay, partially unsupervised. Okay, the semi-supervised learning is nothing but partially supervised but partially unsupervised type of machine learning. Okay, now if we consider an example, let's say a person has given some 10,000 images. Okay, and some 10,000 images, and he asked you to label manually those images. Okay, let's say he said that the images contain dog and cat images, but he doesn't know which image is an dog and which image is an cat. Okay, so here asked you to label the dog and cat images manually. Now labeling this dog and cat images manually is time consuming. Okay, time it increases time and also requires some manual labor. Okay, and also requires some manual labor and also cost. Okay, labeling the data manually increases the pre-processing time, also requires manual labor and also some separate cost to that labor to label the images manually. Means he need to pick each and every image, and he need to observe the image and label the image as a dog or cat. So if we have 10,000 images, it may take less time. But let's say if I have lakhs of data, okay, if we have lakhs of data, labeling the data manually is time consuming, because learning each and every feature, okay, observing each and every feature and labeling is a time taking process. So here comes our semi supervised learning. Okay, now to understand semi supervised learning, we need an example. Okay, now in Google Photos, if you go to collection section, there will be a separate section called some people or group. Okay, people or groups. Okay, we'll be having a separate section in the collections section, like people or groups. Okay, now in this section we'll be having face. Okay, we'll be having our face, and under that face we'll be having some set of images coming under it. Okay, some set of images coming on under it. Now let's say in that section I have my face. Okay, I have my face. Now under my face I'll be having all the images where my face is included. Okay, I'll be having all the images where my face is included. Now let's say in the second column I have my father face. Now in my father face, okay, what are all the images that are coming under my father face comes under this section. Okay, means comes under my father's face. Means this is how a semi-supervised machine learning works. Okay, this is how in short the semi-supervised machine learning works. Means initially you label the images. Okay, initially you label few images. After labeling few images, the labels to the next data points are assigned automatically. Okay, means let's say you have labeled few images. Okay, let's say out of 10 images you have labeled 3 images as dog and 3 images as cat. Okay, now rest of the 4 images are labeled automatically. Okay, list of four labels are labeled automatically based on this manual labeling. Okay, based on this manual labeling, rest of the data, okay, sorry, rest of the images are labeled automatically. Okay, this is how semi supervised learning works. Okay, some of the data should be manually labeled and some of the data is labeled automatically. Okay, based on this it is labeled automatically. Means this comes under supervised and this comes under unsupervised. Okay, manual labeling comes under supervised and automatic labeling comes under unsupervised. So we call it as a semi supervised learning. Means it is partially supervised and partially unsupervised. Okay, now our fourth type of learning is reinforcement learning. Okay, I'll be just giving a basic idea about reinforcement learning because it's just an emerging field. So having an least idea about it makes better sense. Okay, now let's discuss about reinforcement learning. Okay, in reinforcement learning you initially build the model. Okay, you initially build the machine learning or deep learning model. After building this machine learning or deep learning model, you directly deploy this machine learning or deep learning model into the environment. Okay, you directly deploy this machine learning or deep learning model into the deployment without any training. Okay, without any training on the data. Okay, here you don't train your machine learning or deep learning model on the data. Okay, you don't train your machine learning or deep learning model on any data. Okay, you don't give your machine learning or deep learning model any data. Okay, you don't do any training over here, but just directly deploy the machine learning or deep learning model into the environment. After deploying in the environment, it learns from the customer responses. Okay, after deploying it learns from the customer's responses. Okay, this model learns from the customer's responses. Okay, now let's see with an example. Okay, now let's say this is our robot. Okay, this is our robot. Okay, now in reinforcement learning we have few terminologies. Okay, this model is called agent. Now in this example, this robo is our agent. Okay, this robo is a machine learning model, so it is called as an agent. Now you directly deploy this agent, okay, this robo in the environment. Okay, the robo surroundings are called its environment. Okay, the robo surroundings are its environment. Now in the environment we have water and fire over here. Okay, now this is the environment of the agent. Okay, now when the agent moves towards the fire, okay, moves towards the fire, you penalty, okay, you apply penalty. Means you develop an penalty function between the agent and fire. Okay, so when the agent moves towards the fire, it needs to be uh, applied penalty. Okay, so when robo moves towards the water, it needs to be rewarded because water is a good thing. Okay, water never harms this robo, right? Okay, water never harms this robo, but this fire harms this robo, so it must not move towards the fire, so it is applied penalty. But when it moves towards this water, it is rewarded. Okay, we'll be having reward function between the robo and water, and penalty function between robo and fire. Okay, this is the agent and these are its surroundings, and this is the penalty function and this is the reward function. Okay, same comes here. Okay, this is our agent and it's deployed. Okay, deployed environment is its entire environment, and when it gives the correct prediction to the user, okay, to the customer, and if he gives a positive feedback, it learns from that prediction. Okay, it learns from that prediction. If the user, okay, if the customer gives a negative review, okay, negative feedback to this model, it tries to overcome that. Okay, it tries to make better prediction. Okay, it tries to make better prediction from the user data. Okay, for the user data. Okay, this is how reinforcement learning works. Okay, now these are all the four types of machine learning. First we learned about supervised learning, second we learned about unsupervised learning, third we learned about semi-supervised learning, and fourth about reinforcement learning. Okay, hope you guys like this video. If you like the video, please like, share and subscribe. Thank you.